Hi, welcome to this tutorial on machine learning end-to-end. In this tutorial, I'll be going over the entire development lifecycle of a machine learning engineer. This tutorial will be divided into two parts. The first part will be on data extraction, feature engineering, as well as algorithm selection. In the second part, we'll go over model training, model evaluation, model deployment, as well as model integration with the product. Now let's talk about data extraction. Data is the most important part of machine learning. Without data, you will not be able to train or create any models to make prediction of any outcome. In this section, we will be talking about how we can extract data for machine learning. Imagine that you're on a team that has built a website with various features. This site at the very top has a search feature which allows the user to make searches about items on the website. Next to the search bar, there is a profile icon such that when a user clicks on it, they will be able to learn more about their subscription and maybe change some settings on the website. Below that, there are several cards which the user can click on. Clicking on some of the cards can launch a video for the user to see, or it can redirect them to an article, or it can lead them to purchase something on the website. Now, in addition to building out the user interface of the website, your team has also instrumented data analytics to track the user behavior. Now, what that means is that for any searches that your users have made, or any render of any components on the website, as well as any clicks of any component on the website, the data analytics implemented by your team would be able to track all of this, and this data is sent to a database and stored there. Now, this technique, data analytics and tracking user behavior, is actually very common in the industry. If you take a look at Amazon.com or Google or eBay, all of these sites have data analytics implemented as a part of the website. And that data is being logged and stored in a database that's owned by the company. So this not only applies for websites, but also for cell phones as well. In your iPhone or your Android phone, any apps that you use probably has some sort of data analytics as a part of that tracks your behavior inside the app, and that data is similarly sent to a database somewhere and stored. This is also true of IoT devices such as Alexa, Google Home, or the Apple HomePod. All of these IoT devices, they're constantly collecting data from the user and storing that in a database. Now, after these products collect data, there's several uses for it, and here's just a few of them, and there might be other ones as well. But one of the uses of this data collection is to create dashboards. A lot of product managers or product owners, they are always very curious about how their product is performing. Well, with analytics, they will be able to build these dashboards to see how the site is performing on a daily basis, a weekly basis, a monthly basis. So for example, they might track some performance metrics such as how many users are coming in and using the site on a daily basis. What kind of features are they clicking on? These are all important for the product manager such that they can use all of that to either iterate on, to improve the site, to boost certain features, or take certain features off if it's not performing well. Now, of course, in addition to building dashboards, we can also use that data for machine learning. Machine learning throughout the years have proven to be something that can greatly enhance the experience of users on a site. For example, it's often used in recommendations. If you go on YouTube, they have a lot of videos that they will recommend for you next to view based on the things that you have viewed previously. The same thing with if you go on Instagram or Pinterest. There's several machine learning models behind the scenes that are making those kind of recommendations to you. So it's all based on data that they collected on the user and using and what that's called is historical data. And based on the historical data that they have collected, they build these models to give the user a more personalized experience. So that's something else that, of course, we can use data for. Now, the third aspect here I put down is error analysis. And I put this down is because oftentimes websites or even apps, they might crash. And so it's a good practice to log errors. And when we log those errors and access them either through the database, we can see very quickly what are the issues that are causing these problems that our users are seeing. And we can take these error logs and give them to the engineers on the team, and they can take a look at that and hopefully rectify the problem that they are seeing. So these are three aspects that I put down for some uses of data. Now, of course, with data collection and using data, we always have to be very careful about this because in recent years, the European Union has come out with something called GDPR. And GDPR stands for General Data Protection Regulation. And this is really to protect the consumer because a lot of tech companies, they're collecting data without the permission or the consent of the user. And oftentimes the data that they're collecting is used to sell them ads or to present information that the user doesn't want. So the European Union implemented this regulation called General Data Protection Regulation, such that anything that's under the European guidelines, any website, any app will need to ask first the permission and the consent of the user before collecting any data. And companies nowadays, they have actually used this as a general practice, not just for products that they ship to Europe, but actually for products that they have anywhere globally. It's just a very good practice to have to first ask the consent of the user before collecting data. Now, another aspect of this regulation is that, let's say that the user has allowed for some time a website to collect data on them, but later decide that they don't want the data to be collected anymore, then what the company needs to do is that they need to go back and delete or completely anonymize those data such that there's no more association of that user with that data. So that's GDPR. And once again, with any kind of machine learning that we do, we have to be very careful and very respectful of people's data, especially more sensitive things like PII, personal identifiable information. Usually what happens in companies is that they have a legal team to review all of the features that a machine learning engineer needs to build a model. And if it goes through that process and the legal team approves, then the machine learning engineer will then be able to use that data for training and building of the model. And now let's move on to feature engineering. Now, feature engineering is also a very important aspect of machine learning. And oftentimes, a machine learning engineer can spend a lot of time just on the feature engineering part. Let me illustrate sort of why it's so important by giving an example. Let's say that for that website that your team has built, we have collected data for a year. And within that year, we've collected about 2 million instances of click data. And this is clicks on the cards on the website specifically. And just for your information, if you're not used to hearing about instances and features, in data science or machine learning, rows are referred to as instances and columns are referred to as features. So oftentimes you will get a data set in the form of a CSV, comma separated value, sort of like an Excel sheet. And you often have these rows and columns. And in this particular example of the car click data, we have 5 different features. So we have gender, age, location, membership, and topic. And all of these are the features of our data set. Now, in terms of instances, as I mentioned, that since we collect the data for a year, we have 2 million instances or rows, and each row represents a click from an individual user. So let's just take a look at the first row, and this is, once again, one click from a user on a card. And when they clicked on this card, we are able to get some contextual information about that user, including things like this person was a male, they're 16 years old. The location where they clicked on the card was in Paris. We know that they also have a free membership, and the card that they click on was related to the topics of games. Now, oftentimes before we train a model, we want to make sure that the features that we're using to feed into the algorithms have some sort of pattern, have some sort of correlation. It's probably not a good idea to kind of go blindly into training a model if you don't have some level of confidence that the features that you have selected have some sort of relationship to each other or some kind of correlation. So typically what machine learning engineers will do to find out if the features are correlated is to build something called a correlation matrix, like the one you see here. Now, there are various tools and libraries that can help you build out this correlation matrix. But in a nutshell, what it is, it's a matrix that is color-coded with a wide range of colors. In this case, if the more red it is, then the stronger correlation are between the different features. Now, the more blue and the darker blue it is, the correlation is the weakest. Now you can see on the diagonal of this matrix, it's all red. And the reason it's red is because when you have the same feature as compared to itself, then that means they should be 100% correlated. But that's not really interesting. What we really want to see is how these features compare to other features in this matrix. And in this case, what we see is that these are the ones I've circled in black are the ones that have the highest correlation with each other. And if we break that down, this is what it looks like. It seems like gender has strong correlation with the topic that the user has clicked on. And also age has a strong correlation with the topic as well. And based on this gives us some level of ideas for brainstorming in terms of what kind of models we can create, right? So we know that gender and age have strong correlation with topics. So one idea is that we can create a model where the input is the gender and the age of the user. And then based on that, we can make suggestions of different topics that they will most likely click on. So what this model is really doing is trying to predict what is the topic the user will be most interested in based on behavioral data that we've collected and trained on. So that's the feature engineering part. And once again, what we've done with feature engineering is that we first looked at the data and found out which features are features that have high correlation with each other and use those as inputs to the model. So now let's take a look at the next topic, which is algorithm selection. Now that you have done your feature engineering, it's time to select what kind of algorithm would be most appropriate to train your model. Now, the type of algorithm really depends on what kind of problem you're trying to solve. Are you trying to predict a class of things? Are you trying to predict a certain value? Like, for example, if you are trying to predict the price of real estate in 2 years, perhaps you need to use linear regression. And if you're trying to predict maybe a class of topics based on text, maybe some NLP algorithms would be more appropriate. So it really depends on what you're trying to accomplish and what you're trying to predict in the end. So going off what we talked about in feature engineering, where we selected gender and age as our input, and we're trying to predict the topic based on that. There are several ways we can approach this. But let's first take a look at the data. So in the data for gender, age, and topic, we see that gender is, it can either be male or female, but those are text, which is different from the second feature that we see here, which is age. Age is of data type number. So 16, 25, 75, that has a data type of numbers. And then the topic is once again text, right? It could be games, photography, it could be about health. So typically when we train a model, depending on the algorithm, we want to find an algorithm that would be able to take in all our inputs. And it seems like more and more from what we want is we want some sort of text to predict another kind of text. But we run into a problem here where age is a number. So one way to resolve this is we can create an age map. So let's say that if your user is from 0 to 14 years old, we categorize that as children. 15 to 21, we categorize that as youth. 22 to 64 as an adult. And anything greater than 65 years old, we categorize that as senior. So instead of having these numbers, we map a range to certain classes. And if we do that transform, then now everything is in text. So now age, since we did the mapping, is now broken down into these different texts. So now completely we have the data set all text-based, which is really great, especially if we're trying to go in the direction of using some sort of NLP or natural language processing or text-based ML algorithm. Now, if we go in this direction, then there are a lot of options for us, actually. We can use LDA, there is Word2Vec, there's Universal Sentence Encoder, there is fast text, and of course, all the transformer models like BERT, Distilbert, Roberta. We have quite a few selections that we can use here. Now, the problem that we're trying to solve here with the example of gender age trying to predict the topic, this seems more like supervised learning problem, right? Because we have those labels. Given a gender age, we have the data for what kind of topic the user eventually click on. If we go back to this data set here, we see that if it's a male and it's in the category of youth, quite a lot of them click on games. So with this example here, we are able to see that we do have input and a target. So our target could be the topics, and the input is gender and age. So with that, we can use any of the supervised learning approaches. Now, with LDA is actually the one here that is unsupervised because it clusters things based on the repetition and the frequency of text that appears like in an article. So I think right away we can get rid of LDA. And out of all of these, Word2Vec is a good one, but let's just say for simplicity, we're going to select fast text. Now, fast text is also quite similar to Word2Vec, where it creates these word embeddings for your inputs. And we can also use the transformer models like BERT and Distilbert and Roberta. I won't go into too much detail about what each and every one of these algorithms do. I can do that in another video, and we can talk about each and every one of these and some use cases and do a deeper dive into all of them. But for this tutorial, we'll just mention that these are some of the more popular ones that are used for NLP, and we're going to select fast text. And fast text is something that actually is used quite a bit in the industry for text classification. And you can use this on other languages besides English. So this is actually not a bad choice. All right, so we are done with the part 1 of this tutorial. And we will conclude this video here. But I will have another video to go over the rest of this tutorial. But thank you very much for listening, and I hope you learned something from this tutorial. Thank you so much.